So now that we've looked at finding non-permissible values, now we need to look at the other side of rational expressions, and this is simplifying them. So think of a rational expression as a fraction such as 9 over 12 here. We can see that we can divide both of those by 3 and simplify it down to 3/4. A different way of looking at that in a more formalized way is to actually write out 9 as 3 times 3 and write out 12 as 3 times 4. We can see at this point the 3's that are common can cancel, and we're left with 3 over 4. Likewise with this expression here, m cubed t over m squared t to the 4th, it involves finding what is common to both top and bottom. So what I've done here is I've written out m cubed as m squared times m times t. And on the bottom, I've written m squared, and I've changed t to the 4th into t times t cubed. Why have I done that and made it more complicated? And to make it more obvious what can cancel. Here we have m squareds that can cancel, as well as t's that can cancel, and we're left with m over t cubed. Writing it this way isn't always necessary, but for the beginning to explain it, it's sometimes useful to see why things cancel the way they do. What we have at the end here is the non-permissible values worked out. These ones have a slash with the equal sign to indicate that m cannot equal 0 and t cannot equal 0. Whether you choose to put the slash in or not is up to you. We're going to come back to this style of question in the last example, but for now we're going to deal with ones that require factoring. And that's going to be a common thread throughout this entire unit, is you will need to factor a lot and you will need to factor often. I often say, when in doubt, just factor. That will lead you to the correct process. So in A, on the top we have 3x minus 6, and the only thing that we can factor out of this is a common factor of 3. When we take that 3 out, we're left with x minus 2. On the bottom, we have a trinomial. We need to find two numbers that both multiply to negative 10 and also add to 3. 5 and negative 2 will work. At this point, and only at this point, can we look to cancel things from the top and bottom. We cannot look up here and say, oh, we have 3x and 3x. Those cannot be canceled because they are terms. They are being added or subtracted. We can only cancel factors, things that are multiplied. So we need to factor first, which is what we've done. Look for things that we can cancel. We have x minus 2 and x minus 2 that can cancel, which leaves us with 3 over x plus 5. So that's the simplified expression. The second part of the question says state the non-permissible values. So just as we did before, I'm just going to call them NPVs just to shorten it up. We take the denominator, we make it equal 0. This being a quadratic, we have to factor it, and lucky for us, we've already factored it once. So we know that this will factor into x plus 5 times x minus 2 equals 0. Split off, we have x plus 5 equals 0 and x minus 2 equals 0. On the left, we'll end up with an x equals negative 5 as a non-permissible value, and on the right, we'll get x equals 2 as a non-permissible value. Question B, again, we'll look to factor it. The top is t squared minus 1. which is a difference of squares. So we will end up with t plus 1 and t minus 1 on the top. The bottom of t minus 1 is actually not factorable. So looking at this, we need to look for things we can cancel off, and we can in fact cancel this t minus 1. Because it is in a fraction, it is the entire denominator, it is like it's in a set of brackets, but those are just never written, just like 1x or x to the power of 1 or the 2 in the index of a square root. Those brackets are just assumed to be there. So we can cancel the t minus 1 with the t minus 1. We could not cancel it with the t plus 1. Yes, they are close, but close is not good enough here. So now what we are left with is t plus 1. And common mistake that happens is the placement of the t plus 1. Is it in the top? Is it in the bottom? Is it in both? While looking at where it was originally, it was in the top of the fraction. It will stay in the top. And there's nothing left in the bottom, but when we cancel, it's like dividing, so it will be over 1. But this step is actually not necessary. You can just leave it as t plus 1. Non-permissible values. We take the bottom, make it equal 0. And with non-permissible values, we do need to always go to the original question. This one's relatively simple to solve. We just need to add 1 to both sides, and we get that t equals 1 as our only non-permissible value here. Flipping to example 3, this is more like the one I showed you at the beginning of this video. There is no factoring because we only have one term on the top and on the bottom. So the easiest way to deal with this is to actually split the fraction apart. You can split the coefficients, the x's, and the y's, which just gives us a visual separation of how we can simplify this. (14/6). Those are just straight coefficients. We can divide them both by 2 and get 7/3. X to the 7th over x squared. We have 2 x's that we can cancel, so we would be left with x to the 5th. Y over y cubed, we have one y that we can cancel, but this one will be 1 over y squared because we have the larger exponent in the denominator. To simplify this back together, we simply multiply these back together. We get 7x to the 5th on the top over 3y squared.